Welcome to TechCrunch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. All about Java, Collection Part 1. Today we are going to present you a live demonstration and implementation of collection framework includes list interface with ARRAYLIST, linked list, vector and stack class with syntaxes and examples. Now before we get into the demonstration of these classes, let's see what is actually collection framework. A collection represents a single unit of object that is nothing but a group. It represents a set of classes and interface. Before we get into the technical terms of collection framework, let's first take a look at the example. Suppose I have a basket of fruits and vegetables and I need to sort it out and categorize it according to their type, color, sizes or anything I want to make it as per my requirement. So what I did, I picked one basket and categorized by fruits and another basket categorized with vegetables. Now I'm going to put and sorted out all the items according to their type. So fruit basket contains all the fruits like apple, banana, orange, berry, melon, cherry, and vegetable basket contains all types of vegetables: carrot, potato, tomato, pepper, lettuce, broccoli. Now when I bought these things, I need to pay the money. So another type of item which is in a group, in a collection, is your money. So that is inside the wallet. So you can see I have 3 items, out of which 3 are different types of items which is grouped in an object form. So when I have a class of fruits or vegetables or class of money, I can create an object of it and I can use it in a collection form. So that is actually a collection framework. So it represents a set of classes and interfaces. Collection framework represents a unified architecture for storing and manipulating a group of objects. So benefit of collection framework, other than the other type of list, we can make it with the help of arrays or any other way, is it can be manipulated, the complete group of objects. It has interfaces and implementation, that is classes and algorithm and many more. Now let's take a look at the hierarchy of collection API. So collection framework is mentioned in Java in the form of an API where you have the topmost interface called iterable. So you can see the blue blocks are nothing but the interfaces and the red block is nothing but the classes. So, and you can see the bold arrow mentioned as an implements and the dotted ones mentioned as an extend, since it is a class. So when we have a topmost interface iterable, that is nothing but the implemented the collection. Then we have the next level of interface is called collection interface, and this collection interface contains 3 sub interfaces like list, queue and set. Now these interfaces are further categorized and has extended with their subclasses like ARRAYLIST, LINKEDLIST, tag and vector in the list part. The queue section has a priority queue, DQ and array queue kind of class, and set has hash set, linked hash set, tree set and sorted set. So in this session we are going to cover list part, where we are going to see array list, linked list and stack and vector in our collection part 1. In the next section we'll see about the queue, and this is how we are categorizing our sessions for collection framework. Now, when it comes to the list interface that has our subclasses ARRAYLIST, LINKEDLIST, tag and vector, let's take a look at it in detail one by one. Now, before we get into it, let's make sure we have imported our util package where we contain all these type of classes. So, collection framework exists inside the util package. Now, let's take a look about the list. List is nothing but, of course, organized form of presentation of your objects or list of objects or items. Now, when we say list is a child interface of collection, we have seen in a hierarchy where the list is nothing but the collection interface, child interface of collection interface. It is an ordered collection of objects in which duplicate values can be stored. Now, list interface is implemented by the classes of ARRAYLIST, LINKEDLIST, vector, and stack. That's what we have seen in this hierarchy. You can see list goes extended with the ARRAYLIST, LINKEDLIST, stack, and vector subclasses. List is an interface that instances of list can be created by implementing various classes. Now, as you can see the syntax here for the list interface. So as we know that list is an interface, so what we can do, we can just implement our list interface in our class, and we can make an object of it and use our classes constructor. So this is the syntaxes you can use. List, a list equals to new array list, list object name, new your another subclass name constructor, that is linked list. So this is how we can mention list C and new vector, list D equals to new stack constructor. So we will see these classes, their constructor functionality one by one in detail. But for now, all we need to understand, these are types of list, and the classes we are going to discuss next are nothing but implemented by these interfaces. So before we get into in detail, let me give you a quick review about interfaces. We are going to cover it in the next session soon about interfaces and abstract classes. Interface contains, for now just to understand, interfaces contains a method definition which you can override in your classes or use it in your classes. So list is an interface which contains all these method definition what we are going to implement it in our classes. So this is what the meaning of interface is, and list is a child interface of collection, and this interface has all the method definition that we can use in our further classes, like addition of an element or removing, deletion or insertion or pushing, or any kind of method definition. You can find it in list interface and use it in your classes. Array list is a resizable array implementation of the list interface. It implements all optional list operations and permits all elements including null. Arrays are fixed, whereas array list is dynamically defined. So all we need to understand is how it is different from array, or regular arrays we define in our previous classes. This is dynamically defined. You can grow in the runtime. And arrays, we need to declare the array size in the definition only. Now let's take a look at the example of array list. The syntaxes to definition of array list is array list declaration is like this. Array list, the class name, and this is what the generic form we have seen in our regular course sessions. This is called a generic definition. So what we can do, we can mention the data type in this type of generation, the generic definition. This arrow, this type of signs is defined in generic definition. An object name, the new, and the class constructor with the generic definition of the data type. Now, since it is mentioned the data type is string, so it's something like we have a fruit basket and we have defined is like this basket is only for fruits. So fruits is nothing but the string, it's a type and type of the list. And here the type of the list is based on the string data type. Now what we are going to do, we are going to add the string. So we can add the string with the help of the add method. You don't have to traverse the entire list. And you don't have to define the size of the list. All you need to call the add method and include your list and keep adding your element. So this is what the benefit of array list. Now you can also remove from the list using remove method without traversing, without going to the indexes, what we do in a regular arrays. So this is what the difference from array and array list. It returns, now we have few more methods which are popularly used like object.set, object.get, object clear, object size, object contains. So all these methods help you to access this type of list. Now let's take a look at the demonstration. What we are going to do here, create a Java class with maintaining the list of objects using ARRAYLIST implementation. For example, we need to make a list for bookstore and list down the books in the store with the following details like title, author, publisher, price, book ID, or any such any specific things. So here the type is going to be mentioned in a string for title, author, publisher, price, and price will be your integer type, and book ID will be your string type. So for now, just to make it simple, let's take a look at the title and let's implement and see how the array list work. So this is my Eclipse IDE, and here I am going to create a new project, and that will be a Java project. And let's take a look at the collection demo. It's already contains. Let's make it here. And this particular project has a package. Let's give a name. Make sure you're not using any keyword for your name of any class name or any method name. So let's have a list demo. So I created a package and I created a class. Let's see, you can do it at once. You don't have to do it twice. So this is my list demo, and we can have our public static void main in the beginning before I forget. Now what we are going to do here, we are going to create actually we should create a class name called bookstore. It's gonna make, see, this is showing some error. The reason the class name is different, I can rename it. It should be fine. So this is what the advantage of using IDE, that will help us to rename it and without any such, if it still shows some error, see. So this is fixed. Now what we are going to in this class or inside this main method, first we have to create our array list, and that array list with the generic form of string, and object name you can mention book, and new array list, string, your generic definition, and constructor. Now it's showing me error. The reason, we need to use Java util package. See, because the collection is defined in this package. Now all you can do is just book. You can see all kind of methods you can use in your class. These all methods you can use it in your collection API application. Now I wanted to add book name complete reference. Or there are so many ways you can do this, or you can say thinking in Java. So this is how we can add in array list. I have head first. Now another thing what you can do, create another list of price of the book and make it integer type. So price dot add, you can give some number. Your complete references cost 250. Your thinking Java cost 120. I'm not sure. I'm just giving random number. Or your head first cost 500 or 400. And now I wanted to print all these values. So for displaying, all I can do is name of the book. And what I can do for string, since it's a string type, str. This is one of the kind of a loop you can use in a case of array list interface or in case of any collection framework. So here what you need to do is giving the object. So what is going to happen? The string will read and check the object and print until the list is completed. So this will make it your excess of collection in a dynamic form, str. And another kind of integer, int price. You see? Okay, sorry, this is supposed to be p. So what will happen here? We need to give p. So if you see the execution of this, this will print the name of the books and the price of this book. It's a Java application, so we see the execution in the console. See, name of the book, and you can have here price of the book. And what else you can do here? You can also operate like remove or add at the index, a specific index. Suppose I wanted to remove, so that will also possible here. Remove given index. So suppose I gave 0. So let's see what will happen here. The execution will be like this. It removed your complete reference, the very first object. So what you did, you just created collection of list in the book object, and that can be accessed randomly, dynamically, and manipulating it anyway. Remove all, remove last, remove first, remove this, or any form. Now add. If you see the execution now, it will be added now. So this is the live demonstration of array list. Now we have seen the array list. Next, let's see linked list. So Java linked list is an implementation of the list and DQ interfaces. It is an ordered collection and supports duplicate elements. Linked list class uses a doubly linked list to store the elements. It provides a linked list data structure. It can contain duplicate elements. It maintains the insertion order. This class is non-synchronized. In Java, linked list class manipulation is fast because no shifting needs to occur. Java linked list class can be used as a list, stack, or queue. Now, in short, we have seen the linked list data structure. I would like to refer you for my algorithm sessions. There you can find out some sorting algorithms used linked list type of data structure. Now we have seen the data structure, linked list data structure mentioned in this way: head, previous, data, and next. This is a node and this is our heading part. When we have the last null pointer, that goes to the end of the list. Now when it comes to the doubly linked list, it's like we are moving backward and forward, kind of a two-way street. Now in case of Java, linked list collection type of class, it is by default in the form of doubly linked list. It contains the duplicate elements, and since it does not work with the data, process the data, so it will just see the pointer. So it can contain duplicate elements. Now it is not synchronized. The reason, since it is a doubly linked list and it can access randomly any element at any time, so behaviorally linked list is not synchronized. Synchronized means here, whenever we try to access the data of a node, there is no such protection or any kind of key or any kind of dependencies will be there. You can access at the same time. So this is what the synchronized means. In Java, linked list class manipulation is fast and no shifting needs to occur. Now we have seen the data structure linked list where we performed all kind of operations on that: addition of node, removing of node, add all or add at last, or remove last and remove all. So all these methods we implemented using array, and here you can use it. You can create a node and use it, the nodes or data, using linked list class. Now let's take a look at the demonstration. Again, we are going to do the same way. We're going to create a linked list maintaining the title of the book in price using linked list implementation. So this is my Eclipse ID. I am going to make linked list here. You don't have to make any changes technically. The same class, linked list. Now this is showing error. The reason, the package, we can include it. Now if you try to execute this, because they have the same operations over there, so there is no difference. See, name of the book, complete reference, thinking in Java. So what we did, we just defined a linked list type of class and type of the data, and access the same method. Now the difference here, what you will see, if you check the methods, you can create a clone and descending iterator in case if you want to print in ascending order or descending order. So you can use descending iterator. Or there are few methods which has been used to access and having such operation to perform. So this is the only difference in your linked list. Now let's take a look at the so this is what the live demonstration of linked list. Next is vector. Now vector class implements a growable array of objects. Vector implements a dynamic array. That means it can grow or shrink as required. Vector is synchronized. Now here what you can do, you can directly access any data at the same time and have some legacy method which collection framework does not contain. It extends abstract list and implements list interfaces. If increment is specified, vector will expand accordingly to it in each allocation cycle. But if increment is not specified, then vector's capacity get doubled in each allocation cycle. Now if we know the vector is nothing but there are two ways to define our list of objects. One is the type and one is the indexing. So vector will help you to index the object and access that object in two ways, with the particular cycle performed by indexing, reading the indexing, or just getting the value. Vector defines three protected data member: capacity increment, element count, and element data. Capacity increment contains the increment value and element count, number of elements currently in vector stored in it, and element data is array that holds a vector is stored in it. Now let's take a look at the example. You can see here what we are going here. We have two arguments in vector add method. One is indexing and another is the data. So all you can do is indexing or adding the value. Now another thing what we are doing, so what is happening, we are mapping these add values and creating a list. It will be more clear when actually we see the demonstration. Now for vector, what we can do here, we can use and we don't need this time, and we are adding complete reference here, and what I can do is if you see book dot add indexed and string element, index and collection string element, add all, add element. So what I'm going to do, I'm going to have an index like 0 and element is your complete reference. So this is how I'm going to define my vector. Okay, so this is what our vector. We are using indexing, and that indexing will help you to link your object from other element. So it start from 0, I'll make it 3, and your data, any string value, you can give another name of your Java nail it book. Now so we have 4 data. Now we need to have our price object, so you can have your price different in a form or like this, you can have, basically what we are doing here, we are using different types of objects with different types of items. So categorization, accessing, manipulating of objects in a data, accessing the data in a different form based on their requirement. So in case of vector, what you can do, you can using the indexing and mapping the object, and you can implement it in your code. So I have integer type I equals, instead of equal, this API has this type of definition, and here I can get the value from print value of I. So what will happen here, we need the price to print, we need to define the price of the book. So price dot add any value, price dot add all, or add, yeah, even you can do all. What will all do is let's take a look at the example. You can even do the clear in the end. So this will add all, 230 will add to all objects. So this is what the implementation of vector. All we need to understand, the vector is the synchronized type of collection where you can access the data at the same time, and you have a key using mapping method, and indexing will help you to access anytime from anywhere at the same time. So this is all about the vector. Now we have seen the demonstration of vector, and now let's take a look at the stack. Stack is a type of a data structure we have learned in the what is actually we follow it. We've had the last in first out type of theory in the data structure where we put the values inside, that is called push, and when we take it out or remove, that is called pop. The topmost pointer called top, and the bottom is the bottom. It's like a bucket, pouring the water and take it out the water from the top. Now, when it comes to the Java collection framework, it's itself a class that extends the vector, which implements the list interface. Stack class extends vector. It also grows and shrinks its size as needed when new elements are added or removed. Stack operations, if you need to check if the stack is empty, find the size of the stack, search for an element in the stack, iterate over a stack using Java for each method. We have seen iterate over a stack using iterator, and the same way you can use for each remaining. And iteration basically help to see you're traversing the data from top to bottom using list iterator. So these are the special methods you can find in the stack class that you can use it instead of writing those methods as for your variables in the array implementation. That's what we have done so far in the regular structure. Now, in case of stack, the stack definition is just like this: string, disk, and the name of the object, and the constructor with a generic form of definition. All you need to do, push, pop, search, and iteration, and all these methods you can use to access the stack. Now, let's take a look at the demonstration. We are going to create the class of the bookstore and have the book name and the price printed in a stack. So, one stack will be for the book name, book title, or another is for price. So this is what we have: bookstore class, and we have vector. Now here, instead of vector, we are going to use stack. You might be thinking, like, what is the difference when we are just simply changing this and making it work? The difference is the method it defines in this class. I haven't used all of those methods. There are so many other types of methods which are being used many different ways. That what you can use. Now, as you can see, it is simple enough to understand. We don't have to create a node. We don't have to create a stack. We don't have to create a specific class or array structure or definition. All we need to create an object of that class, and that object of the class with that specific generic type can be used to push and pop. Now, what I can do here, instead of add, I can mention push. 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 So this will add the edit in the stack. To understand the complete implementation, what you need to do is it's a linked list. Let it be like this. There are 4 books, I'll keep it 4. Now, first we need to check whether the stack is empty or not. So for that, what you need to do is we need to iterate using for each loop and check if it is empty or not. So let's see how it works. So this is your stack. We have inserted the name of the books, book titles. Now suppose I need to remove it. So what I can do, pop method, and I can just see how it will pop. Now here I have just called the pop and it removed the the last title of the book randomly. Now in case I need to remove, so here you can see you can mention the indexes for remove element. In case I wanted to pop, it will automatically just calling the method without any arguments, so it will remove my another book too, like head first. Now in case if I wanted to add again, so this will, since the last in first out theory will come, so this time the head first will be the last one. This will be on top. So complete reference, head first is the last now. So originally head first was third. Now if you see, it is now fourth. It is again the third, but we don't have the nail it, no? So that's why the indexing is now. Now again, if I wanted to pop, so now we have only 2 books here. In case if I wanted to push the complete reference again, so this time the complete reference will be twice. So you see, the nailed it and thinking in Java has been removed from the list. So last in first out, this is the theory is going on in the stack implementation. Now what actually you can check is, if in case if you popping all the elements and you need to make sure that your stack is not empty, you can check for the null. This is how we have worked. Stack is empty. So this is what the implementation and demonstration of stack. Now let's see about the important facts between these 4 types of list. Array lists are dynamically defined. They are non-synchronized, as we know the regular arrays are fixed. When it comes to the linked list classes uses a doubly linked list structure to store the elements. It provides a linked list data structure that contains duplicate elements, and they are also non-synchronized. That means you cannot access the data at the same time or any random way. Vector is the type of data structure which you can synchronize, can be accessed at the same time, and implements a dynamic array. That means it can grow or shrink as required. Stack class extends the vector. It also grows and shrinks as it's needed when new elements are added or removed. Now let's have a practice project for homework. What you can do here, we can create a Java project with class called library, where we are maintaining the list of books with details, author, title, publisher, and book ID using ARRAYLIST, LINKEDLIST, vector, and stack type of classes, as we have seen doing in bookstore here in the example. For any kind of assistance or source code required, please contact techranch2019@gmail.com. Thank you so much for watching this video. Please subscribe to our channel to stay tuned for more upcoming interesting and informative sessions. In the next session, we are going to cover about DQ of collection part 2. Let's make coding fun. Thank you.